Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is huge grid. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. We are given a binary sequence A of length n. So with this string of length n, now what we need to do is we need to construct a n cross n matrix. And this matrix will be called B and it will be as follows. For all the indices of Bij, where I is less than equal to j, the value of B of ij is going to be nothing but summation of all the elements that are in between the indices I and j in the given initial string. Now, and for any other value of B of I and j, that would mean that where j is greater than I, it will be nothing but B of j and I. So in case where our I is less than equal to j, so if we think of this as a square matrix, so all the values that are above this line are the case where I is less than equal to j, and all the below are where j is greater than I. So for all these cases, what we are going to do is we are going to fill it with the summation of the elements at the index I till j, and for all the ones that are below, they are going to be symmetrical, so mirror values of whatever is in the upper right triangle. Now, we define a path going from 1 comma 1 to n comma n as a sequence of pair, that is usually the positions in our n cross n square. Now, in this case, we need to find the minimum possible path sum in such a way that we can reach from 1 comma 1 to n cross n. Let's see the input format. We have t test cases, and for each test case we are given two lines. The first line will contain the integer n, and the second line will contain a binary string of length n. As for the output, we simply have to output a new line that will contain the minimum possible path sum. As for the constraints, number of test cases will go from 1 to 10 raised to 5, value of n, that is length of the binary string, will go from 1 to 10 raised to 6, and the elements in our binary string would be 0 or 1 since it's a binary string. Let's see some sample inputs. So for the first sample input, the length of our binary string is 3 and the string given to us is 0, 1, 1. So with this, what we can do is we can draw a 3 cross 3 table. So something like this. Now in this, if I have to put indices, forgive me, I think it will be better if I just draw it. Table came out pretty small. So again, where were we? We are going to draw a 3 cross 3 table. Something like this. Now if I plot indices, this is 1 comma 1, this is 1 comma 2, and this is 1 comma 3. Similarly, this is 1, 2, and 3, right? So now this will become 2 comma 1, 2 comma 2, 2 comma 3. This becomes 3 comma 1, 3 comma 2, and 3 comma 2. Sorry, 3 comma 3. Now if you see, as we have discussed, all the values in the upper triangle are cases where I is less than equal to j, and all the other cases, the below one, are where j is greater than I. So what do we do when our j is greater than I? We simply replace it with the value of b of j comma I. So in this case, 2 comma 1 gets replaced with 1 comma 2. In this case, 3 comma 1 gets replaced with 1 comma 3. These are mirror values. These are symmetric. Now what we need to do is we are going to start from there 1 comma 1 and we need to reach here 3 comma 3. So now if I start filling the values, right, again, this is our string s, or you could say string a, and the values from I to j. So for a b I comma j, this is nothing but the sum of all the elements that are between I till j, right? So 1 comma 1, it is 0. If I go 1 comma 2, it is 1. If I go 1 comma 3, it is 2. Similarly, if I am from 2 comma 2, the value is going to be 1. If I go from 2 to 3, it is 2. and finally 3 comma 3 is just 1. So what we can do is we can start from here 0, we can go to 1, then we can go down, then we can go right, at the end we can come again to this. So with this the total sum is 3 plus 2, 5, and as you can see that's the answer here. As for the second test case, we have the value 4 as our n. Since all the values are 0, whichever path we take, it will be of no cost to us. Therefore, the answer is simply 0. Let's see how we can approach the solution. Now, as we have seen, whenever we are talking about the value of b of ij, what we are actually doing is we have the numbers in this range from I to j. And what we are doing is we are adding up all the elements that are in between. If I tell you that we have to do the next step, that we are going to move. So when we move, as we can see here, we can either move to the right or we can move to the down, as we have seen here. So what does it mean to move to the right? If I move to the right, the value of j is going to increase by 1. It means one additional element is going to be included into our value of the next position. But if I move down, what would happen then? If I move down, I is going to increase by 1. It would mean that one number or one element is going to be removed from the sum of our path. So it is always beneficial that we take I plus 1 comma j. Now since we know that the upper right triangle and the lower triangle are symmetric, so we can choose any one of the halves to traverse. So let's say we start from this where both I and j are 0. Now whether I move down or right, it doesn't matter, right? So what do I choose? I can choose anything. I can choose to move down or I can choose right. So let's for simplicity, let's say I move right. So now in this case, now I have increased my I to I plus 1. Then there are two elements that are here now. So what should we do? As you have seen here, if you move downwards, what you're going to do is you're going to remove one of the elements. So now if you move down, you will change to I plus 1 comma the value of I plus 1. So now there's just single element at this path. So with this, you can keep on moving right, then left, right, and then left. And with this, we'll reach from 1 comma 1 to n comma n. And while we are doing so, you might have noticed that at any point of time, since you're always increasing and decreasing, the number of elements in the range is always constantly 2. And since this is a binary string, the max value that we are going to get is just 2. So we start from 1 comma 1. We can either go down or right. So in this case, we have chosen to go right. Move to the right, add the elements that are in the range to our sum. Then we move down. Then again, we move right. We keep on doing so until we end up reaching n comma n. And once we reach this, the sum that we will have will be the minimum, and this will be our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and then our string s. Now once we have that, we are going to start from 0, 0, since the index based in our programming languages are from 0. So we are going to move from 0, 0 to n minus 1, n minus 1. Since if the indices are equal, we can choose to move either down or right. Both will give us the same value. So for our just preference sake, we are going to move right. So moving to the right means increasing j by 1. While we are doing so, we will add the previous value that we are at. Since both I and j are equal, only one element would be added at that cell. Next, in the other case, what we are going to do is we are going to move downward. That would mean that we are going to increase the value of I. While doing so, we'll add the previous value that contained two of the elements. We add this and we keep on going until we reach n minus 1, n minus 1. With this, we have calculated the part and we are with the minimum value. So at the end, we print this, and as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and then our binary string s. We start from 0, 0 and we want to reach n minus 1, n minus 1. To do this, we keep on moving right and then down. We add the value of those cells to our sum. At the end, we obtain the minimum path sum, And as we print it, you can see that I've got an AC in my Python implementation. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.